All right, guys, welcome back. Let's dive in. Today's random fact: the heads on Easter Island have bodies underneath them. Who knew? All right, let's look at discovering slope-intercept form in its full form today. We've talked about slope. Let's bring in everything. Okay, we've got y equals 1/2 x to start with. And that's the graph we see here. This blue line is the graphed line of y equals 1/2 x. I want to point out, if we didn't know anything about slope or how to count it, and we just knew that x is the input and y is the output, we could proceed forward just by plugging in some values. Now, I'm going to multiply whatever's with x, whatever's next to it, which is 1/2. That's multiplication, they're stuck together. I'm going to pick numbers that multiply to a whole number when I multiply by 1/2. I'll put a negative number in there, 0, because it's always good to know what 0 does right on the y-axis, and a positive number. And if we plug each of those in, we would just be seeing what each of those would equal. So literally, if I put in -4, 1/2 of -4 is exactly the same as saying 1/2 times -4. 1/2 of -4 is -2. Okay? And then if we take that out and put 0 in, well, 0 times anything is 0. And then, of course, 1/2 of +4 is 2. So, if we didn't know anything about slope, we didn't even know anything about a slope-intercept equation, we were simply plugging in some values that someone gave us, notice what we get. Okay? The first one here, -4, -2. If we graph that guy, we would go over to -4 on the x-axis, okay? Come over to -4 on the x-axis, and then down 2 to get our point. Now, to be clear, I'm just graphing a point. I'm even going to erase that. That is not us counting slope. That's just you seeing where I'm going here so you can track with me. So maybe I'll say here, 0, 0 is right here. 0, 0 goes right there. Okay, we'll make that a blue point. And it's right there. And our third one, 4, 2. You guys think I'll ever get through a video without mistaking the marker for the pen? I don't think so either. 4, 2, I'm going to go over 4 and up 2. And it's right here. Remember, we're always graphing points x value, then y. That is how you graph. Now, notice what we have here with our 3 dots. If we were to count from any of these to another, and I wanted to get slope, I could go up 2 and over 4. That was up 2. It was over 4. And someone might be saying right now, well, Mr. A, you kind of missed a shortcut. You could have gone a shorter distance. And you know what? You're right. I was using the points I was given. But there's another point that the line crosses in the middle of those. And I could just count up 1 and then over 2. And notice what we get. Whether we use the green slope, and remember, we call this rise over run. It's always up, down, y value on top, and then run is going across. Remember, it's always the y over the x, okay? We could see this as 1/2, or if we counted the other one, it's 2 over 4. Again, rise over run, y value on top, but that just reduces to 1/2. So either way, we see that we created a line with a steepness or a slope of 1/2. And then if we look back up to where we just started, we already saw 1/2 at the beginning in our equation. The point here is we could shortcut all this work. If you guys wanted, you could do this for every single equation the rest of the unit that you see. Anytime it's got a y and x, you could just plug in x values, calculate out, multiply with that fraction, get your y values, and graph that way. But it seems like we could do it a lot simpler. So let's do this. Okay, now we're back to our beginning. What if we instead recognize that anything that's right next to x, whenever you're talking about linear equations, we've got the form y equals mx. And this spot right here, m, is any number that's multiplying with x. And its name is slope. And again, we don't know why m is slope, but notice if it's right there, we don't need to do any calculating. The whole purpose is just to be able to count and say, okay, this slope is telling me I go 1 up and I go 2 over. It's always the y value over the x. So the 1 up is on y. There we go. The 2 over is on x. There we go. And I can keep doing that. Okay, that's how our slope translates into a line. Now, where should we start that line? If we had a blank slate here, we would always start at 0. So even though I started there, the starting place would be at 0 on this line. Up 1, over 2. Up 1, over 2, and I will continue to get points on that line that I can graph. Now, what about moving this line up and down? Right now, if we just have a slope, we'll always be located at 0. All of our lines will go right through that point. Is there a way we can break these lines off of 0? Let's see. Okay. The blue line is the original one we just did. This is the y equals 1/2 x. It's got a slope of 1/2 and it's stuck at 0. Do you guys know what that equation, what the equation of that line might be? What we notice is it just moved up by 1 unit. Instead of crossing at 0, it now crosses at 1. And if I show you the equation of that line, you probably will figure it out on your own. You don't need me. The equation of that second line is y equals 1/2 x plus 1. And the original I'll put right next to it, y equals 1/2 x. I wonder what causes that drift up by 1 unit. I know, really tough, right? So tell me, what is it going to look like if on the next page we're going to graph a third line, and the third line is going to be that equation. Think about it for a sec. What do you expect the third line to look like on the next page when I flip, if that's the equation? I'm going to go back to a page with a little less on it, just to not be so messy. If we looked at our third line, the y equals 1/2 x plus 1, that's where he crosses the y-axis. So our y-intercept here equals 1. And I covered that up. You can't see the 1 anymore, but there's a little 1 right there. And we see right here where our brown line crosses the x-axis, and there's his x-intercept. -2. All right, it's time for you guys to do a little more. Were you correct? Because there it is. -2 brought our line down 2 points. The +1 moved the line up 1 point. And I'm doing those little curved arrows just so we don't get confused about slope. We're not counting up and over for slope, we're just noticing how this line changes. And in this, we now discover the B. So we've got y equals, and we know m. M's our slope. And we've now just discovered as well that whatever we add or subtract at the end of the line moves the equation up and down. Okay, so the b on this equation of +1 moved the whole line up 1 unit. The b on this equation, -2, moved the whole line down 2 units. And right in the middle, we just had y equals 1/2 x. And there was a b. Do you guys know what the b was? If it goes right through 0, what is the b? It is +0, which is why we don't ever write it. Because +0 is the same as saying nothing, so we normally don't write that. You can see the difference there. Let's make this explicit. Let's define this right now for you. Okay, so m equals our slope. Okay, it's always going to be written as the y over the x, and it's often called rise over run. Okay, the b is called our y-intercept, which is actually a term we need to define right now. The intercept is where any line crosses, or any graph crosses that axis. The y-intercept is just where your line, where your graph, we're not going to say line because it'll be true for every unit of functions we do. And I bet based on that, you can already tell me what the x-intercept is, can't you? Intercept, by the way, means to cross the path of, to come in line of something. So when your graph intercepts y, it's crossing y. When your graph intercepts x, it's crossing the path of x. So the x-intercept is just where your graph crosses x. I should say the x-axis, to be clear. Okay? Those are really important to know. Those are fundamental graphing terms that you're never going to get away from. You're going to constantly see those. So let's go back up and look. For our original graph, right here, that doesn't have any plus anything, we can see that right here in the center, that's the y-intercept, a y-intercept of 0, and it's also crossing x at the same place. Only at 0, 0 are they both exactly the same, but our original graph has got a y-intercept and an x-intercept at 0. Let's look at the green graph. Where does it cross each of those? Right here is where he crosses the y-axis, so he has a y-intercept of -2. And we already knew that by looking at our equation, because our equation tells us where it's going to cross the y-axis. It's how your line is shifted up or down. The whole line shifts in that direction. The x-intercept of the green line is right there. It crosses the x-axis at 4. And I'll switch to another color. It might be getting a little bit messy. You know what? Just to work in me to talk a little less. All right, here's a few example lines. I will do the first one to show you. And what I want you to do is first, find the slope of the line. Second, look for the y-intercept, which can then write the equation of the line for you with the slope. And then tell me what your x and y intercepts are. I'll do the first one. So for my example green line, I'm going to start by looking for some places it crosses there, it crosses there, it crosses there. So I'm just going to count, and I go up to over 3. So I know that my slope, which I now call m, is 2 over 3. Always the y value on top, and because it's going upward and over, it's a positive slope. Okay, now I'm going to look for my intercept. I know my equation is going to be y equals, let me just write the whole thing out for you, y equals mx plus b. So I know I'm going to fill in my slope of 2/3. It always goes with x. And now all I need is my intercept. My plus b is my intercept. So I'm going to look for it. It's right there, and it equals 3. Plus 3, and that's because the y-intercept equals 3. Okay, now, that's all we need is those two pieces of information in order to write the equation. That is slope-intercept form. There's your slope, and you plug it in right here. It always goes right here. There's your intercept, y-intercept, okay, which is right here. And then y-intercept, by the way, is b, so I should have written that as well, okay. B is the same as your y-intercept, m is your slope. And then as far as x-intercept goes, it's just good to know that, but be clear, an x-intercept is no part of this equation when we write it. X-intercept is just good practice for you guys to know what one is. And if I look for my x-intercept on this equation, it's right here, and it's in between two lines, so I would guess it's about -4.5. It ends up landing between two values, and that's okay. All right, you guys pause it and work on A and B, lines A and B. What is their slope and intercept? Write the equation from it. And then can you also tell me what the x-intercept is? Go. All right, if you're back, let's look. Let's start with A. I'm just going to pick some points. And notice you can pick your points anywhere you want to graph. I'm going to go way over to the right here, so I'm out of the way of everything else. I see that I've got to go down 1 and over 3. And when I count downward, that's a negative. So -1 and 3. So line A, the M, is my slope, and I see that it's -1 over 3, because we always write the y over the x. Now let's figure out my B. My B is my y-intercept. So I look, and there's my y-intercept. It's where my line crosses y, and it's at -2. Now I'm just going to write these together as my equation. Y equals, and those two spots are where I fill in. My m, or my slope, goes right there. My b goes right there. And I'm sure someone's got the question, can I write plus -2? You absolutely can. I would recommend getting into the habit of just writing -2. But plus -2, we know at this point it's equivalent. Mathematically, it's exactly the same, so that is something you can do. All right? Now, what about my x-intercept for line A, which is not part of the solution, but in case we were curious where it's at, and it kind of got buried right there. And we can see that my x-intercept is -6. That's right where my line crosses the x-axis. All right? Let's do the second line. Let's move that out of the way so we have some room. Line B. I'm going to count. I see a point here, and I see another one here. I'll count right there. 1, 2, 3. And notice we're always starting on the left and counting to the right. So that means I go up 3, I go over 1. Direction matters. So please always count up and then over. It'll keep your slope correct. And if you guys are wondering why, if I just randomly put the 1 and the 3, maybe I count this direction or something, you're right. You are going to get the 1 and you are going to get the 3. But if I'm not clear, I'm going to start guessing. And some people are going to write that for slope. Some are going to write that for slope. And I'll ask you right now, one of these slopes is wrong. Which one of those slopes is correct and which one is incorrect? What do you think? Okay. Always y over x, which means 3 has to be on top. That's correct. That's incorrect. That's why we're careful about how we draw our slope arrows, to make sure we always get the slope correct thing on top. 3 over 1, and remember any fraction with 1 on the bottom, you can also just write as a whole number. So we can also just call the slope 3. 3 over 1 equals 3. And what's my b? Let's go look. Where's my y-intercept? And it's right there. It's right where I started counting for this problem, which is at 1. So we've got a y-intercept of 1. That's where it crosses the y-axis. So there we go. So now my equation, y equals, and again, just plug in. There's my slope of 3, and there's my intercept of plus. Now see, it's positive 1, so we need the plus. It's plus 1 because it's above. Minus 2 on line A because it was below, so use the sign to make your intercept. And then last but not least, if we want to figure out our x-intercept, just so we get familiar with those, your line B has an x-intercept. It's not quite on a whole number. It's kind of out there in the middle. So we would guess that your x-intercept, where it crosses x, is at about negative 0.4. And that's an estimate, of course, guys. So anything you're saying between 0 and 1, hopefully below half, that's closer to 0. But you've got the idea, right? This is the main thing you're shooting for. Can you write the slope and the intercept into your equation? That's what we're shooting for at this point. That's really important. All right, moving forward. All right, guys, here's your homework. Billy Bob is trying to learn slope, and he's trying to learn his equations. So he's got those two lines, and he went ahead and found his slope, found his intercept, and wrote his slope-intercept equation from that. You need to check through his work and see if he did it right. Fix any mistakes you might find. All right, that's it. See you guys.